Fine. So let's start the session. Okay. Okay. Good evening, everyone. Myself, Seshan. I've been, training students on, data science, AI, and ML. So all these stuff. I'm having 7+ years of experience, and I'll be your, guide as well as your trainer for, these 30-hour program, which is actually starting from today. So this will be your first day, and we'll go through the introduction part of trying to understand that. First of all, what is machine learning and what we are going to learn through this course of this 30-hour program. And we will be doing multiple things in this program, and we will be learning a lot of stuff. So let me just guide you, or let me try to make you understand that what we are going to do in this 30-hour program for this session. So the first important thing what we'll start with is the foundations of the machine learning part, right? So I've divided into four different modules. So the first module actually covers about the foundations of the machine learning. So in the foundations, we are going to cover different aspects where how or what is machine learning, and why machine learning is actually used, and what is the role of machine learning in the market now, and how we are going to implement this machine learning into projects, and how we are going to deploy the projects, right? That we will cover. So first we'll understand what is machine learning in the foundations part. Then going to the advanced machine learning part, so learning algorithms like decision trees, right? Random forest, SVM, right? All these things, advanced algorithms we are going to cover. And then coming to the third module, which is the applications, right? So here we are, so when we actually apply this, foundations, or when we apply this advanced machine learning techniques as well, we will try on, or we try to build model using a data sets, a real-time data sets we are going to do. But then again, what is this real world application is? This is more focused on how to deploy a project into the real world. So once we build a model and how we are going to, deploy it into the real world for the predictive analytics part, that we are going to do in the third module, which is the real world applications. So next, coming to the fourth module, which is the capstone project, right? And here we are going to, give students, or I'm going to give students how to actually do a project, guide them, how to implement the project and all those things. So especially, since we are doing this collaboration with the, we are with XLR, we are collaborating with, Mallarity College, and we are actually trying to prepare the students. The main focus of this program, learning all these aspects, which also covers one very important thing, which is preparing for the interviews as well. So this is more focused where people can crack interviews on machine learning, because machine learning is one such area where there is a lot of interest, and a lot of scope, and a lot of requirement, where people need to learn and understand once you are actually implementing, and whether it is data science or analytics, or whether you're implementing business analytics, or whether you are doing AI stuff. So machine learning is one such area where it is very important to know machine learning inside out, how you can implement in the industry. So this is one area what we are actually going to target first of all, by this 30-hour program. So that is the main agenda, and guiding the students, particularly, more focus also on the Mallarity College. So here we also prepare for the interview and all those things. We are going to discuss some important interview questions as well, right? So where we can actually know that I'll be picking many questions from different from my experience, as well as my my colleagues and friends experience as well, and how companies actually frame the questions from data science, particularly focusing on machine learning. So particularly on what is being asked on machine learning, so we'll focus that, whether it might be a starting from a basic questions, to an advanced level as well. Because when people ask questions, they expect big questions also. But when you go to a industry, particularly as a fresher, the more perspective will be on the basic questions first of all. Whether this fellow actually knows what is a linear regression first of all. What is a decision tree? Why decision tree can be used for classification and regression? So very very basic questions they start. Where is bias, variance, trade-off, and so on. So like this, very very basic questions they start, and based on that they go to the advanced level, because they feel okay, fine, at least the basics are covered. So that is what our focus also will be, to make sure that we cover from the basics to the advanced level. So that is the main agenda for this 30-hour program. And I'll give my best to make sure that you communicate, you try to make sure that we understand things, and we take it forward on this concepts what we are trying to learn. So let me just check the questions part. Okay, so I think fine. I think as of now, no questions. Maybe we can go forward. Okay, great. So now let me actually go to the next part. So the first module actually, which covers the foundations of the machine learning, is around 6 hours. So let us go into deep dive into understanding what is machine learning first of all. So before understanding what is machine learning, first of all, we should understand when this machine learning actually started, you know, and how now, how come the generation of machine learning and deep learning, and the one key important word which has been spoken by multiple people now in the industry, which is the word artificial intelligence. So the AI actually started, or you can say the artificial intelligence actually started, in the 1940s, late after the Second World War. So, the foundation for AI has started at that time, right? So let us not go much into the history, but, the foundations for AI has been laid, right? Where, why can't machines do things what human beings can do? So that is in where the foundation of, machine learning actually has been laid. So it is very important after that, after a few years, what has happened. So what has happened is the birth of machine learning came into the existence. So how this machine learning birth has come into the existence is where how to learn. That is where the focus was more focused on. For example, if we want to do a particular thing, right, from experience, as a human being we do from a particular experience. But if your machine wants to do things, right, if it wants to do a certain thing, or it has to do something else, right, so it needs something to learn from it. That is in where the foundations of machine learning has come into. So it's just two words, machine and learning. So that became a big limelight kind of right now. So it is basically a machine is actually learning, right? So it is actually trying to learn what it is trying to learn. So how the data is actually transforming, or the characteristics in the data. So how the data is actually behaving. Actually, what we are learning from, what the data, what we are doing with the algorithms is understanding the data, one word, right? So we are understanding the data. So data is nothing but people, right? So we are trying to understand the people. So how the behavior of the customer is, how, a particular customer buys a particular product, how, how many people are interested in a particular product. All these things are achieved from algorithms, right? So that means a machine is trying to learn from a data, right? So that means we are training the machine, right? So for example, like, how do we train on things, right? since we are childhood. So for example, when we are in childhood, right, our mother used to train us, right? So she used to show things and train us and all those things, right? That's the same way what we are doing for a machine. So next, 70s, 80s, 90s was more focused on machine learning. Then came the 21st century, where the foundations for deep learning are actually started, right? So where the foundation for deep learning started. So why deep learning has started? Deep learning is absolutely part of machine learning only. So why it has separately started as a particular subset of AI is because the data has actually increased, right? So the data has actually increased. So now, since the data has actually increased, right? So it is very important for us to, you know, it's a very important for us to train the machine with a huge amount of data. That's where the concepts of big data came into the picture, right? So all these things came into the understanding and limelight. So now here, the thing what deep learning does is it actually uses the neural networks. So we are going to cover some of the concepts of deep learning also, because when we talk about applied machine learning, it also includes some of the concepts like NLP, natural language processing, and deep learning as well. So we will discuss that also through this 30-hour program. So now going forward, this is one of the very important pictures which tells you what is exactly machine learning. So a human being tells that I automatically learn from experiences. That's what actually a human being does, isn't it? So you and me also do the same thing, right? But a machine cannot learn from experience. It needs data to learn, right? So it needs data to learn, right? So here you can see that the machine is learning from the data. Okay, it is not like really studying, but it learns. That means it trains, understands, tests, and uh, you know it validates. So this is how the machine actually learns from the data. So as we already have discussed, AI, right? AI is the bigger picture, right? So here you can see that artificial intelligence is a bigger picture. In that you can see machine learning and deep learning as a part of artificial intelligence. So let us go a little more into as what we have actually discussed till now. So overview of what exactly is machine learning. So machine learning is basically focused on decision making, right? So to make a decision, we need the machine to learn first of all, right? So then only once it learns, there is something called as a model building. So once the model has been built, then the model will be tested, or using the testing data or the validatory data to validate whether our model has been predicting correctly or not. Then we are going to deploy the project into the real world to understand, right, whether we are able to predict correctly what we have actually built. Okay. Now, going into the next part of what we do in machine learning. So the most important thing what we do inside the machine learning is the training of the data, right? Then we apply a machine learning algorithm, and then we can, build a model, right? We call it as a logical model because it is dependent upon logic, because, right? So since it is depending upon logic on the data, we call it as a logical model. Then we try to predict for an output data, which is it might be a testing data or a validatory data. We are going to test it on a new data to claim our predictions of how, what does our model tell you. So now let us go to the classification part. So what is the classification in, I can say types of machine learning. Okay, we say classification of machine learning because, some people get confused if I say classification, because there are two kinds of methods in supervised. One is classification and regression, right? So that is not that classification. Here is types of machine learning, right? Or you can say, the machine learning is broadly divided into three parts. So there is also one more, some people might argue saying, there is something also called as a semi-supervised. I'll come to that also, because actually that is also true, right? So we have unsupervised, supervised, reinforcement, as well as semi-supervised learning as well. So I would say four are there, but we usually classify or broadly divide into supervised, unsupervised, and reinforcement learning. So we'll see each one in detail. Okay. So the first and the foremost thing is the supervised learning. Okay. So let us talk about supervised first, then we'll go to the other two. And also we will touch the semi-supervised also. So now, right? So now understanding about what is, or the different types of machine learning, let me, just take, let me check the chat box as well. So any, so let me, you can put it in your chat so that, I can, so you can just put it in the chat if you have any questions. So we'll just also cover unsupervised also. So you can, we'll cover that as well. Yeah. Okay. I think, right. I think no much questions. I think I can go forward. Okay. Fine. So let us, dig into what is a supervised learning, right? So to understand what is supervised, it is very important why or what is the objective of a supervised learning. Okay. So there is only one objective and very easy to understand. So the objective of supervised learning is to map, right? So, about this mapping, you would have studied in your, school level mathematics, right? So y is equal to f of x, right? So this is what exactly you map your input to the output, right? So how do you give your input and how or what you get as an output? So the mapping is done with the input to the output. That is what exactly supervised learning. So we give some input and we are expecting some output for that particular input what we have given. That's it. This is what is supervised learning in a very simple terms. So now let us understand through a definition first of all. Okay, so once I just told you what is the objective what we are doing in a supervised learning. So now let us see what is the definition of what is a you know supervised learning. So now supervised learning is basically, right, training on the labeled data. Now what is labeled data, right? People keep on telling labeled data, unlabeled data, right? So now let us understand what is a labeled data. So labeled data is nothing but data which is actually or already grouped, right? So for example, now you students are from Mallarity College, right? So you might be from CSE, mechanical, right? So you are grouped into one, grouping, right? Or I can say that as a clustering. So, you are CSE students, you are, mechanical students, you are, civil students. So since you are grouped into one cluster, because why you are grouped, if I ask that question, what will you say? So because we took admission into that, computer science or CSE. So we have been put into CSE class, right? So since you wanted that particular 60 students or 120 students, you wanted to study computer science as a engineering subject, right? So that is the reason you have been, you took admission and you are into that particular group. That means, when you are in that particular group, you are taught the computer science subjects because you are in that particular cluster. That means you are labeled. right? So a particular tag has been given to you, right? That you are computer science students. That is what is basically labeling the data is. That means identifying the data or giving a particular name to the data or identifying the data by a particular label, right? So this is the dog, this is the cat, right? This is an elephant, this is a tiger, right? So categorizing things, right? It might be anything, right? So categorizing things, right? For example, if you take gender, male and female, right? So you're categorizing two important classifiers. One is male and female. So you're labeling them, right? If a person looks like this, he's a male. If a person looks like this, he's a female. So she's a female. So you're categorizing them, right? That is what exactly is labeling. So training the labeled data is what exactly is supervised learning. So after training, we know what to do, right? We build a model, we test, we already spoke about that. But now let us, the more focus is currently on the supervised learning. So now in the supervised learning, so I told you that the objective of the supervised learning is basically about mapping the input to the output. Fine. Now, next important thing is what is exactly supervised? So supervised is basically, labeling the data. Okay. So once the data is already labeled, then we take into supervised learning and we train, because we are telling training the labeled data. That means the data is already labeled, right? Where it is labeled? It is labeled in the unsupervised learning. Something which comes into unsupervised is an unlabeled data. There it will be labeled. Then it comes to the supervised learning where we train the labeled data. For example, if the data is not labeled and it is coming for training, it is not correct, right? So it is, you cannot apply any supervised methods. You have to first send the data to the training part, sorry, to the labeling part, which is done in the unsupervised. So first labeling the data, then coming into the supervised learning. Okay. Now, coming to the algorithms, what we are using, there are many algorithms which we are currently using in the market, and we are also using some ensemble techniques as well. So some of the very basic algorithms are, under supervised learning are the linear regression, logistic regression, decision trees, random forest, support vector machines, neural networks. So all these algorithms, including much more algorithms also, we are going to cover in this session. Okay, in this session means in this 30-hour program. So we take up the projects as well on these algorithms, and I'm going to explain you how these algorithms can be applied and deployed. Okay, so now let us see a very basic example, or I can say applications of where this, supervised learning is actually applied. So since, when I told you supervised, unsupervised, and reinforcement, I told you also that there are two kinds of supervised learning. So there are two kinds of supervised learning. So one is classification and the other is regression. So these two are extremely important, characteristics of supervised learning. So everything happens between these two, types or applications, you would say, or, the way they are divided, right? So two important things where the supervised learning works upon. One is classification and regression. So simple way to understand is classification is nothing but predicting something which is not numerical. Okay, so you can, for time being, you can remember like that. Something which is a classifier, right? Something which is classifier, right? Something which is not a numerical value is what classification is. Now, exact opposite is what regression is. Something which is a numerical value is a regression. For example, like a house price prediction. So house price prediction is a numerical value, right? So you can consider it as a regression problem. Stock market forecasting. So stock price is nothing but a numerical value. So that is what regression is. Sales forecasting. It's all regression because it deals with numbers. Now classification is, for example, email spam detection. That means here there are only two classifiers. One is either it's spam or ham or not spam. We say not spam or ham, H-A-M, ham. So either it is it's a binary classification problem. So for example, either it's a spam or a non-spam. Sentiment analysis, whether the person is happy, sad, right? Or, he is neutral, or, he's overjoyed. you have multi-classification problem there, and fraud detection, whether the transaction is a fraud or not. So for example, if you have to predict the transaction, what you do, right? Whether you do it from credit card, debit card, UPI transaction, any kind of transaction, whether it is a fraudulent transaction or not, right? If you have to check by using an algorithm, is it a classification problem or a regression problem? It's a classification problem because we are classifying whether the transaction is fraud or not. We are not predicting any numerical value, right? So all these predictions which doesn't involve a numerical value are basically called a classification problems. So now coming to, yeah, one more important thing I want to add is there are algorithms which are capable of doing both, whether it might be classification or whether it might be regression. So in a few algorithms, for example, if I say decision trees, right? So decision tree is capable of both classification and regression. For example, random forest as well, SVM as well, right? For example, like logistic regression. Logistic regression is capable of doing only classification. And if you say about linear regression, so linear regression is capable of only doing regression. It cannot apply, or it cannot be applied, linear regression cannot be applied on classification problems. But logistic regression, even though there is a word regression in it, it is basically used for classification problems. So now let us try and understand what is a unsupervised learning. So let me just check. So I don't think any questions. You can post your questions in the chat. So I can see a question on what is ensemble learning. So ensemble learning is nothing but a combination of multiple algorithms. For example, for example, like you can think of ensemble techniques as for example, like a random forest. So random forest is an ensemble technique. So techniques like bagging, boosting, like that, we have many techniques which are involved, where it actually mixes different algorithms, and it actually builds the model. So that is what an ensemble technique is. So right now you have I can say the reality is something where yeah the reality is something where we are mostly focused on ensemble techniques because you're not able to build a model using a particular algorithm actually. So things have changed. So you can use ensemble techniques in different areas. For example, like decision making. I'll come to that random forest and I'll explain that. So maybe you can just wait for coming sessions, because we'll actually do the random forest in detail as well. So at that time, I'll explain as well. Okay, fine. So just to move forward. It is important for the interview because ensemble techniques is one question where definitely you'll be coming across, because there are certain methods in ensemble techniques like the bagging and boosting. They are extremely important. So I'll take up also questions on that and I will explain that. Okay, you can just wait on that particular concept. When it comes, we are going to discuss that as well. Okay. Okay, so let me move forward with the concept what I'm discussing. So unsupervised learning is where the data is basically unlabeled. So something which is comes in the form of unlabeled data, which is not been grouped, right? So which is not grouped or structured, or you can say the grouping or clustering. So the technical word what we use is clustering or grouping. Okay, so how do we identify the things, or how do we identify the data and cluster them into groups? That is what basically is the unsupervised learning about. So the objective, particularly of the unsupervised, is somewhere where you have to identify the underlying structure in the data. So, or you can say how the data actually behaves, how it can be put together into one cluster. That is what the main objective of unsupervised learning. So now coming to the algorithms, what we use. So the main important algorithms what we use is the two clustering techniques, k-means clustering and the hierarchical clustering part. So here k-means clustering and hierarchical clustering is where very important clustering techniques they are. So we have much more like the fuzzy c-means clustering, right? DB scan and all those things. But the main primary two clustering algorithms which we use is the k-means and the hierarchical. And then we have something called as a principal component analysis. So PCA is a very important part it is actually a technique which is used in dimensionality reduction to reduce the dimension of the data. That means the size of the data. Size doesn't mean rows, right? It doesn't mean records. Okay. Size indicates the features, which is the columns in the data. Ideally we want less number of features or columns in the data to process and to go ahead. Okay, so that we can do using mathematical technique, right? Applying linear algebra and all those things, right? The concepts like matrix and all those things, and we reduce the size of the data. That is what principal component analysis is basically on. And next we have one more thing is the autoencoders. So ideally autoencoders is also a concept which is used for dimensionality reduction. Then what is the difference between PCA and autoencoders? Is very plain and simple. Let us not go much into PCA and autoencoders now, but one thing to understand why we are using PCA and autoencoders is PCA is mostly used for linear data and autoencoders is used for non-linear data. That's as simple as that. So you can remember that as kind of right now. So now applications of what is unsupervised is basically about the customer segmentation, market basket analysis, anomaly, and recommendation systems. So these are some of the applications which you can think of when you talk about unsupervised learning. So semi-supervised, that's what I was actually about to tell you. So semi-supervised is, mostly not shown in, different, when we talk about different types of machine learning. But, I feel semi-supervised also should be considered. Why? Because if you have some unlabeled and, some labeled data, you have to combine, and if you have to, process the data, like image data, speech recognition, medical diagnosis data, text analytics, all these are coming under semi-supervised. And actually it is very difficult to process these kinds of data if there is some labeled and unlabeled. This is the tricky part. That is why most people do not want a combination of both semi-supervised, or you can say super labeled and unlabeled data. So that is why either they segregate into labeled and unlabeled separately and they process, right? And in some situations they try to process together as well. So it is based upon how the company or the project is actually upon. So next is the reinforcement learning. So reinforcement learning is the thing which is currently going on in the market right now, because the applications of AI, whatever you are seeing, best example is your autonomous vehicles, right? So self-driven vehicles, right? The AlphaGo games, robotics, and everything. These and all come under the reinforcement learning. So very simple way to understand what is a reinforcement learning is. Reinforcement learning is basically about learning from experience, right? So that means you try to learn, right, from the things you have done, right? And you give rewards, you give feedbacks, right? You give penalties, you do multiple things in order to teach yourself. So you have to teach yourself and you have to, right, you have to learn. That is where the reinforcement learning comes into the picture. Right. So this is the next we'll see the life cycle of machine learning. So the it starts with gathering of the data, then it goes to the data preparation part. So most important thing, which is not mentioned in this, life cycle is the problem statement. So first of all, we have to understand the business problem, right? From that business problem, we have to from that business problem, we have to just give me a minute. From the business problem, how we want to solve a particular business problem. Based on that, we try to gather the data or the information, what we want to do or satisfy that particular, business problem. How do we solve it, right? So that, because first of all, we should know which data we have to collect or gather. So it is based upon the kind of business problem we have or a business scenario, right? Where we want to solve something for our business, right? Either we want to increase sales or whether you want to, stay in there or stay in the market, fighting the competitors. It might be any kind of problem or any kind of scenario. So to, approach your business problem, you have to understand your business problem first. Then, based on your business problem, which kind of data you need to collect, that kind of data has to be collected. So now, if you don't, if you don't understand the business problem properly, what happens? If you don't understand the business problem properly, you don't collect the correct data. So obviously, everything will go wrong. The data cleaning process, data wrangling, analyzing, training the model, testing the model, deployment, everything goes wrong. And when you deploy the project, the predictive analytics part doesn't work well, right? So everything is becoming, all the things what you have done is going into waste, right? Because your predictive analytics is not working properly. What exactly you want to do, that aim or ambition or objective is not being satisfied, then what is the use, right? So it is very important as a data scientist or a data analyst or a business analyst to first understand the business problem. This is the trickiest part, right? Or a very important part, which is, a base. You can think of it like a base, a very important base to address your situation using data science or analytics. So first, you should understand that how you are actually going to understand the problem and how you are going to act upon it. That is very, very important. Then only the other 7 steps are important. Please understand. So then, we start gathering the data or collecting the data on our requirement. Then we go to the data preparation process, right? So data preparation, where we try to, adapt different kinds of techniques like, cleaning, normalizing, all those things. And then we go with the data wrangling process, right? All the EDA process and all those things. And then we go with the analyzing of the data, right? Apply the techniques, right? Mathematical or statistical techniques. Then we train the models using machine learning and deep learning techniques. And then we test the model, right? And then we go into deploy the project and we try to predict. So since we understood the business problem correctly and we gathered the data correctly, obviously all the other things will go smoothly as per plan or process. Now let us see some of the applications. By this time, you would have understood why we are using machine learning, first of all. So, there is no field, I can say, where machine learning is not used, particularly like, automatic language translation. So, right, wherever, text to speech or speech to text, right, Google Translate, all these things you can, AI and ML are used. Then you can identify or think of medical diagnosis, right? And then we can, understand the stock market trading. Then we have the online fraud detection, right? So the transactions where we can predict whether the transactions are fraud or genuine. Then we have the virtual personal assistant, right? Like the, Google Assistant. Now Google has come up with Gemini as well. And then we have the, Apple's Siri, and we have Samsung's Bixby, and so on. And I think Vivo Jovi, right? So like that, we have different voice assistants or personal assistants. And then we have the email spam and malware filtering. And then we have the self-driven cars. Then we have the product recommendations. Then we have traffic predictions, then speech recognitions, image recognitions, and so on. Here are a few applications I put. So, if you go to finance field, economics, right, medical, right, you have n number of applications where machine learning is used. There are like, n number. You cannot even, think of, okay, it can be used this field, you'll be surprised. So these are some of the applications. Still, I felt, you guys should be knowing apart from that. So healthcare, you can detect any kind of disease based upon, data sets. And then we have the drug discoveries, then, personalized treatments, then medical analysis. Particularly, I would say AI and ML is helping people, particularly in the medical field. So it's one field where AI and ML is blooming, and it is doing a lot of wonders in the field of healthcare. And then we have the next thing, which is the finance field, where we try to predict using the credit score and loan predictions, and then we do the fraud predictions and detections and all, then risk assessment and so on. So next, coming to the retail and e-commerce field, we have the personalized recommendations, then inventory, demand forecasting, and customer sentiment analysis. So these are, every you can see these applications being, applied onto, customers, the way the customers actually, their behavior, the purchase capacity, the way they purchase things, the way they behave. So all those things are, considered. Then the transportation field, where the traffic predictions, route optimizations, and so on. So entertainment, you can see, machine learning being used in the fields of, content recommendations as well, like your Netflix, Amazon Prime, Spotify, and all those things. And then you can see the speech recognition, then, your video games and content creation. So manufacturing field, where you can see in the supply chain, robotics, and quality control. So in the energy, where we have the fault detections, energy consumption, and so on. So agriculture, where you can predict using the crop yield, then pest detection and weather forecasting and all those things. So these are some of the key concepts which we understood in the machine learning. So let us go a little deep into understanding what is a feature. Okay, so there are some of the things like features, labels, training, testing, and validation. So we will see that in detail, okay, and try and understand that what are these features. So features are nothing but the columns in a data set. Okay, so one small example, what I have taken is, if you take a house price prediction model, right? So house price prediction basically comes under a regression problem. So number of bedrooms, location, right? Year built, square footage, all these things are columns. So in technical or in the corporate industry, we call these columns like, square footage, number of bedrooms, location, year of build, right? Parking space, all these things as features. We don't call it as columns. So columns is something where, as a simple terms, we call it as a columns. Or there is one more simple term which is called as a variables. But what we call exactly in the industry is, we call it as a features. Okay, so these are basically the inputs for the data. So here you can see that there are different kinds of features. When you talk about features, there are different kinds. For example, like numerical, categorical, textual, and time series. So numerical is where the anything which is a numerical value. So like age, height, and salary. Then categorical is something where gender, color, region, right? So textual is in the form of a sentences, reviews like articles and all those things. Then time series data, whether using the weather data or stock prices and so on. So next is the labels. So labels are nothing but the dependent variables. Okay. So for example, or target variable, you can say. So either they are for example, if you take an example, let us understand with an example. It will be easy to understand through an example. So if you take spam filtering, right? So email spam filtering. So the sender subject line, whether it is spam or ham. So these, so the features here are email content, subject and, or you can say subject line or sender. But what is labeled here, spam or not spam? So what exactly you understood by that? So what is a target variable? So we also call it as dependent variable. Okay, or you can say it as a target variable. In the industry, we call it as a target variable. So whatever, or the output variable, maybe you can also think like that. It's an output variable or it's a target variable. So next, what is a training process? So training is nothing but teaching the machine. In a very simple term, what is training is we are teaching the machine to learn what we are teaching. Now the next question is, okay, fine, sir, we understood, you already said that we are teaching the machine. Fine, okay. Now, what we are teaching the machine? So we are teaching the machine about the features and labels. Now, what exactly is happening when we teach the features? So it will understand how the data is actually behaving. So what happens when we teach the machine, right? It tries to learn what is exactly happening, because what exactly we want is the machine has to learn without errors. That means what we predict and what is actual should be correct. So it has to learn from all the important features or content in the data, and it has to predict the outcome correctly. So what is actually the predicted value, right? And what is the actual? There should not be much of difference between what is the predicted as well as what is an actual value. That is what is called as a training of data. Now there is a technical word to understand what is the difference between a predicted and an actual. That particular technical word is called as a loss function or error. In simple terms, we call it as an error. But in machine learning language, we call it as a loss function. So the difference between the actual and the predicted value is called as a loss function. So now let us go to the testing part. So testing part is nothing but how our data, once it learns from the data, its characteristics and all its behavior, how it is actually, learning the characteristics or features. It is learning how the data is behaving. Then we are going to test it on an unseen data. So that is what the testing is about. So let us, we are evaluating, I can say. It is like, we teach in the class, right? After that, we conduct one exam. That is called as testing. That is what the evaluation process is. So we are evaluating, right? So what we are doing in the classroom session is training the students. So we are training and then we are testing by conducting one exam. That is what the training and testing is about in machine learning as well. We are training the machine and then we are conducting like an exam for the machine, stating that, right? So predict and see. Let us see how much prediction you can do correctly. That's it. Same like how we conduct for students. You can link the same thing. What happens with the training and testing. With the training process, what we do actually in the class. So next is the very important key points, such as there are some of the metrics we use. So I'll also explain the metrics. When we talk about the algorithms also, because it's a very important thing that you need to understand about the metrics also. So there is different metrics like accuracy, precision, recall, F1 score. We have mean squared error. Also, we have something called as a root mean square error also. RMSE also we have. So loss function, and we have many things which we do. Okay, so a lot of techniques are there. So for example, like mean square error and root mean square error is basically used for regression problems. And techniques like accuracy, precision, recall, F1 score is basically used for classification problems. So now let us understand the next important concept, validation. Uh, Let me just check for any questions. Maybe you can post it in the group also. Yes, loss function and cost function are different. They are both not same. Let me just check. I think not many questions, one or two questions I got. Yes, cross validation I'll explain. So it's a kind of validation process. I'll just explain. Just let me check the for the questions. Loss and log loss are not same. Are not same. I'll come to that. Okay, so I think not many questions. I think we can go ahead. Um, Fine. So let us see what is the validation process, right? So we have already seen what's the testing process, but there is something called as validation as well. So why this comes? Okay. So the biggest concern, particularly when we train the data, is the overfitting problem. This is one of the issues where we try to do this validation process. So either the model might overfit or the model might underfit. So to understand what exactly is overfitting is something where the data works well with the training and doesn't work well with the testing data. Okay. So if the data is working well on the training, and it has to also work well on the testing data, but if it doesn't work, we call it as overfitting problem. So why this problem occurs is, instead of capturing the important features in the data, the model is actually capturing the noise as well. So noise is the unnecessary disturbances in the data. So it is capturing the unnecessary things in the data set. So this is not good for model building. So, if that happens, what happens, the model will perform well in the training and it doesn't perform well in the testing process. That is the problem of overfitting. We have to avoid this problem. For underfitting is, something where the it doesn't work well in the training as well as it doesn't work in the testing problem. So, if this happens, we again have to apply the validation process. So validation process is a kind of different kind of analysis what we are going to do, where we try to do our best to avoid this two problems of overfitting and underfitting. And also a very important process is using the hyperparametric tuning. So now in this technique of validation, we are using methods like cross validations, holdout validation, stratified sampling. So stratified sampling is one of the statistical methods which tries to split the classes into a balanced way to train the machine. So there are I think you would have come across techniques in sampling methods, like simple random sampling, stratified, and systematic sampling. These are the three big sampling methods which exist in sampling techniques. So in that, we are going to use the stratified random sampling, right? So in validation algorithms. So there is one more called as cross validation. So cross validations is something where we divide the data into k subsets. So k might be 10, it might be 15, it might be 20, or it might be 2. It is based upon the size of the data. And then we train that many number of times to check whether the validation process is happening correctly or not. And one more thing is leave out, or we can say leave one out cross validation, where we leave one data point and train on the other and test on that data point. Like that, we do a number of times as well. And holdout validation is splitting the data sets into multiple validation processes. So like this, we are going to apply different validation processes if the data is going to overfit or underfitting. So if the data is not going for overfitting or underfitting, it's not a problem, right? We can actually you know go ahead. But this problem of overfitting and underfitting occurs, then we have to find a way to use these techniques and sort out the problem. Fine. So let us discuss this and let us go for a short break. Okay. So let us understand the difference between these concepts. Now, what exactly the relationship between features and labels? So features are nothing but the inputs or independent variables, and labels are nothing but the dependent variables or the outcome variable or the target variable. Now, training and testing is nothing but the training is basically done on 60 to 80% of the data, and validation is done on 10 to 20%, and testing is done on 10 to 20%. So usually we divide the data first of all into training and testing. So usually it is a 70-30 process, 70% on training and 30% on testing. But things get different. We use the testing data, and sometimes we also divide the data into a validation process if the data is actually overfitting and underfitting. So that is how we try to solve the problem of overfitting and underfitting, because it is a very common problem when we try to train the machine. For example, if we train the machine and there is no overfitting or underfitting problem, actually in reality when we build projects, if we don't get any overfitting and underfitting problem, we should consider ourselves very lucky actually, because this is one such problem which occurs most frequently than not. So it is, I can say 90% of the time you can expect a problem of overfitting and underfitting, right? So that is why the data validation process, the data pre-processing also will be done, and applying dimensionality reduction is also done. All these processes are followed in order to make sure we don't have the problem of overfitting and underfitting. So let us take a short break, and let us continue of understanding what is data cleaning and all those aspects. Okay, just give me a minute. So yeah. So let us continue. Let me share my screen. Okay. So now let us go a little deep in understanding what is exactly the process of data cleaning, handling, different kinds of data. So whether it might be, missing values or outliers or duplicates or any kind of. So this is a process where it comes under data, pre-processing. Sorry. So it comes under a data process, data pre-processing steps. And let us understand why it is very important to pre-process the data, right? Because it is a very integral and a very important part of the machine learning process. So this is, these are some of the basic things which, you need to understand before, jumping into a algorithm or a project. So first of all, let us talk about the missing values or how to handle the missing values. So there, obviously, why a missing value exists inside a data. It might be, many reasons, right? So it might be a, data collection error. It might be, retrieving the data error or, very reasons, typo errors, right? So it might be because of different problems, different scenarios. This missing values might actually occur inside the data. Now, let us start by understanding, how we implement it in Python. Okay, so we will implement these in Python, but I just wanted to show on a shorter note why or how it can be implemented in Python. So we use a very small function or syntax called as isNull and dot sum. So what it does is basically adds all the null values inside each column, and it will give you the sum. So like this, we can apply a small functions in Python. That is why, when we apply machine learning or deep learning, we use Python as a, a basic language, because Python is a user-friendly language, I can say, which is basically used for data analysis. So next, how we apply to handle the missing values. So we have a function called as a drop. You can drop the rows as well as we can drop the columns. So here you can see that axis 1 indicates that you are dropping a column, right? If you give axis 0, it is basically a row. If you don't give anything, it is basically a row. Or if you give axis 0 also, it means it is a row. Okay, or it is called as a record. So next, how do we, input these values? So we input these values by using, different functions, right? So one of the functions is by replacing it by using mean, median, and mode. So you can either replace this missing value by using mean, median, mode. So these three are the measures of central tendency. And you also have a function called as a forward or a backward filling. So you can use this forward and backward filling. For example, if you have observations like 10, 10, 20, 20, and a missing value, and again 30. So forward fill will again 20 fill, because in the forward direction you can see the 20. So backward fill is exactly opposite of the backward fill. So we have also, these forward filling, backward filling are little outdated, I can say. Mean, median, mode also are, particularly median is a method which is mostly used. Mode we are not using for replacing a value, basically. We don't use mean sometimes also, because if there are outliers in the data, mean is not a very good function. So median is a, I can say a standard function, because median is a positional average. So something which lies at the exact middle. So, replacing the missing value with a median value is a very suggestible thing. So interpolation is basically used for time series data. So interpolation is nothing but method of Newton's interpolation, forward and backward interpolation. So it was actually found by Newton. So it's a very useful mathematical method which is used to replace the missing values in a time series data particularly. So next is the handling the outliers, and we handle the outliers by building a box plot. So box plot is something where we try to identify the outliers. So this box plot can be achieved by using a library in Python which is called as a Seaborn library. So Seaborn, like there are two kinds of visualizations. One is the Matplotlib and Seaborn, and Matplotlib is basically used for basic visualizations. Seaborn is more of a statistical visualization library. And boxplot is actually, since it's a statistical measure or a statistical visualization, it comes under Seaborn. So you cannot use Seaborn without using Matplotlib, because Seaborn is built on top of Matplotlib. So next is the how to identify the outliers. Very very important method also after box plot is the interquartile range method, which is called as an IQR. So here in IQR, you are going to calculate the 25th percentile and the 75th percentile, and you are going to use the IQR formula, which is Q3 minus Q1, and we are going to apply the lower bound and the upper bound by achieving through the formula Q1 minus 1.5 IQR and Q3 plus 1.5 IQR. So once you have identified the lower bound and the upper bound, we are going to something which is less than the lower bound is considered as an outlier, and something which is greater than the upper bound is considered as a outlier. So we use the AND condition to identify the lower bound and the upper bound. So how to handle these outliers? So we can remove it or we can apply the transformations, or we can apply the cap and floor techniques as well. So now next is identifying the duplicates. So this is a very tedious task of identifying the duplicates and removing the duplicates, and because what happens is it will lead to some biased results, right, if we are using or going forward with using of duplicates. So we need to remove it. So a very small function is what df dot data. Df is nothing but a data frame, which is the table in the form of rows and columns. So df dot duplicated, you can use the function to identify the duplicates. Next is the identification and then dropping the duplicates. So first we have to identify whether I can say the function identifies the duplicates, but whether it is actually a duplicate or not, that we should understand, and we should take a decision whether we have to keep the duplicates or we have to delete the duplicates. So the best practices what we use for data cleaning is it is very important first to visualize the data. So particularly by creating a histogram, right? Because we use something called as a distribution plot as well. So distribution plots, histograms, scatter plots, and box plots will make you to understand whether the data is in a smoother way, where the data is following a normal distribution or not, whether the data is symmetrical or not. So by these methods we can identify whether there are some anomalies. Anomalies are nothing but abnormal observations in the data which need to be removed, because they are very dangerous for the data analysis. So whether the data is an outlier or whether the data is anomaly, what is the need, whether we should delete it or what should we do with this. So for this we have to identify the data first, and by using the visualizations, then we have to understand the context and we have to process the data. So whether it might be we have to understand the why I said understanding the context is when such example is the duplicate example, what I sometimes it is actually not a duplicate, right? It has to be retained in the data. So we have to make sure what we are trying to do, what is our business problem, what exactly we are trying to do, that we have to have a understanding, or we have to make sure that we process it by feeling that how exactly the data or what is the context of it. So next is the document changes, where we have the data cleaning process, and then we have to automate wherever you can use the data cleaning process. For the we can use the same script where you can automate the process. So next we'll go with the very important, basic concepts of machine learning is the feature scaling and encoding the categorical variables. So now let us first understand that. Let me just, just give me a minute. Let me see any questions. So I think not many questions, I guess. So about scaling, I'll just tell you. Okay, I'm about to explain that concept. Um, Fine. Okay. So let me process the concept. Fine. So let us talk about the feature scaling because I don't think there are any doubts. Okay. Right. So feature scaling is nothing but an technique which is used at the pre-processing step. So you can remember that when we talk about data pre-processing, the very important thing is the feature scaling, right? So what exactly is feature scaling is about? So talk about let us talk about the concept of scaling, right? So what is exactly scaling in a normal English language? So scaling is nothing but bringing on the same page for comparison. For example, if we don't do feature scaling, okay, what happens if you don't do the feature scaling? So you will not have all the variables or features, let us say features or variables or columns. These variables will not be on the same page. Then to build a model and to compare, right, to train them, it is very difficult. So, and particularly, this feature scaling is done to columns or features with a numerical value because we are applying a mathematical formula, or I can say a statistical formula to scale the variables. So now let us go into understanding why this feature scaling is actually done. So this feature scaling is basically done on algorithms, right? Where the convergence is very slow. Okay, let us not go little deeper into what is convergence. Okay, so it will again, be a little, more mathematical side. But why? What happens if we use? I'll tell you. Very, because we are saying, a certain concept, we are using it in the industry, or we are saying we are using it in the, machine learning algorithms. Let us say what it does. So it actually helps the algorithms to converge fast. So or I can say the models to converge fast, or I can say the, scaling does, or the scaling helps you to bring all the features on the same page, right? So that is what scaling is basically is. Okay, so we apply two different algorithms, particularly which are sensitive to magnitudes. So that is what scaling is basically. So there's also a technical term, right? So it is basically called as normalization. Okay. So the normalization is nothing but, those who are familiar with statistics will be automatically understanding when I say the word normalization. Okay. So it is typically bringing the values to a, you know, closed interval 0, comma 1. So that is nothing but mean and standard deviation. So there's a very small formula which is used. So x minus x minimum divided by the x maximum minus x minimum. So when you do this, right, we don't apply this formula manually. You need not worry and remember the formula, not required. When we use, sklearn, which is the scikit-learn, and we have a very important function in that, which is min max scaler. So in that min max scaler, automatically the scaling will be done. So there is a small function to apply this, which is the min max scaler. That is one thing. And there is something called as a fit underscore transform. So when you apply this fit underscore transform using the min max scaler, automatically the features are normalized using the formula x scaled, which is x minus x minimum divided by the x maximum minus the x minimum. So this is a pure function which is being followed, which is a part of normal distribution. So next is the standardization process. So in standardization process, we have something called as a z-score. So z-score is what the mean zero and standard deviation 1 is actually achieved. So here the scaling process appears in the form of x minus mu divided by sigma. We apply the standard scalar, right? For applying the minimax scalar, right, or the normalization, we also call this also as normalization only actually, but this is called as a z-score normalization. This is called as a min-max scaling normalization. Okay, both are use the same techniques of normal distribution only. So we apply the scalar where we apply the standard scalar as well. Then comes the robust scaling. So robust scaling is basically it uses the median and IQR techniques. So you can say, or you can remember, like it uses the percentile method to identify the outliers. So then we have the log transformations as well. So now let us go to the next part, which is the encoding. So what is encoding is, so the scaling part, feature scaling part is done for the numerical values. So then what about the categorical variables? So for categorical variables, we have something called as an encoding. So what is encoding is nothing but giving the numbers. Okay. So, if we hear the word encoding, we think of, oh, this is a big process. No, it's not a very big process. It is basically assigning a number. For example, if you take gender, okay, so there is male and female, right? So for example, for male we give 1 and for female we give 0. That is what is encoding. That's it only. So giving numbers or unique numbers, or giving a unique identifier for a particular categorical variable. For example, if you have a scale of 1 to 5, where we have good, very good, right? So like that, if we have a scale, right, if we have 5 categories, so we give 1 2 3 4 5. Okay, but here when you use the encoding, it starts from 0 because it's an array way of giving. So 0 1 2 3 4 4 till 4 it goes if we have 5 categories. So something which is categorized, right? And we also talked about the example of spam or ham, or you can say spam or non-spam, right? There are 2 categories, so it gives 0 and 1. Okay, so giving numerical value or a unique identifier to a particular categorical variable is what is encoding is. In a very simple term, that is what encoding is. Okay, so we use the function called as a label encoder. This label encoder processes, or you can say pre-processes the data, and it will fit into the data and it will try to encode. Okay. In that, we have different techniques like the one-hot encoding and binary encoding. Okay. So why one-hot encoding is used is it actually processes the data, right? If we have to, particularly create a dummy variables, there is nothing much difference between binary and one-hot encoding. So simple way to understand is if you want to create a dummy variable, you use the one-hot encoding. If you don't want to create any dummy variable, you don't want to create an unnecessary column extra or a feature, you use the binary encoding. That's it only. It's in a very simple term, you can remember like that. So next is the frequency encoding. It actually identifies based on the frequency of the categories. Okay, so if we don't know how many categories are there, we can use the frequency encoding. And then the target encoding is where we have to identify or replace the categories in the target. Okay. So next is when to use what. Okay, this is a very important criteria. Okay, we know that there are many encoding techniques, right? So which one to use at which place, right? That is what a very important concept which has to be understood. Let me just check for questions. This. I think not much. Okay, I think no questions. You can go ahead. Okay. Fine. So when to use which kind of scaling technique or encoding technique we have to understand first. And now let us see why, or we already understood when to use scaling and when to use the encoding. So standard scalar is basically something which uses or assumptions are being done using the normal distribution process. So whether we are using for example like PC and logistic regression. So something which uses the normal distribution, right? So it follows the normal distribution. We are going to use the standard scalar. So min-max scalar is basically used for KNN and SVM, which are based upon distance-based methods. So KNN is nothing but K nearest neighbor. SVM is support vector machines. So robust scalar is used where the dataset contains outliers. So when the data is outliers, it is best to use the robust scalar. Next comes the encoding. So encoding is where the label encoding is done for small, medium, and large data sets. And one hot encoding is done for very fewer categories. So target encoding, or you can say frequency encoding, is basically done for high cardinality. That means there are more categories. For example, like 10, 15, 20 categories. Then it is always better to use the frequency or a target encoding. Okay. One hot encoding is basically done for when there are not more than five. Yeah, I remember using it for not more than five. So it is very important to understand which kind of encoding will be used for which kind of process. So let us see now what is a dimensionality reduction. Okay, so dimensionality reduction is basically a process of statistics where we use it in machine learning as well to reduce the size of the data. So it is nothing but the reduction of size means that reducing the size of the features or the input variables. That is what sir, what if we you may get a doubt thinking that sir, if we reduce the size of the features, or if we reduce the size of the uh, you know I can say you're saying variables, input or input function or features, if we reduce the size. So how do we follow, right? As I told you, we have some mathematical methods which will be applied. Okay, fine, fine. So will we not lose out on the important information? So that is one important thing which comes to mind when we are using the dimensionality reduction. So, to answer this question, we follow the protocol for normal distribution where we want to retain 95% of the information. So if you are, if you want to drop some dimension, right? So you want to reduce the features or variables or the input variables. So the best possible way is to follow the normal distributions protocol of 95%. So, for example, you have some 35 variables, right? So you have used the techniques of dimensional reduction, whether you are using PCA or autoencoders. So, you have to make sure, right, that, 95% of the information is retained at least. So if you're able to retain more, it's good. But at least 95% should be retained when you are applying the dimensionality reduction. So that is what the normal distribution tells us, whether you are applying for linear or non-linear data. So PCA is applied for linear and autoencoders are applied for non-linear data. So why use the dimensionality reduction? We already have seen why we use the dimensionality reduction. It is basically used to reduce the size of the data, and it is basically to enhance the features to retain not to go with too many variables, which actually can lead to overfitting problem. So for example, you have 35 variables, and when I applied PCA, and the data is linear, and if I'm able to now I'm able to reduce only to 20 variables, and I'm able to capture 96% of the information, or the 96% of the features or attributes, or the things which can be captured. The model can, or the variables are explaining 96%. So I'm fine with it. So it's okay that I'm losing the 4%. But the biggest happiness for me is I'm reducing the size from 35 variables to the, or from 35 features to 20 features. So it is very important, and it is easy for me to train on that particular features where I can avoid this overfitting problem or underfitting problem. So that isn't where this dimensional reduction comes into the picture, and it is a very important concept when it comes to applying machine learning in the industry. So there are some of the methods in dimensionality which we already spoken about, and some of the things are the feature selection. Feature selection is a very simple word to understand. Selecting the very important features which are required for our process. That is what basically feature selection is about. So then the feature extraction is transforming the lower dimension things. So, sometimes what happens is we are going to merge, different features, right? So that we apply by using mathematical techniques. So we combine the features to achieve this feature extraction as well. So we do apply different things to achieve different things, right? So next is the key techniques. As I already, we have already spoken about the PCA. So this PCA, I'm not going to go much into the, mathematical stuff, but what PCA uses is the principal components, right? Principal components are nothing but the very important features. This uses the variance covariance matrix, eigenvalues, eigenvectors, all those things which we use in the linear algebra. It uses all those methods, and based on that, we are going to identify the principal components. And then that is what we are going to do in the PCA process. And then we have the LDA, which is the linear discriminant analysis. So here we are going to combine the features for the classification task. And then we have one more very important one, which is the t-distributed stochastic neighbor embedding. This is a this is a method, or you can say this is a dimensionality reduction technique, which is to preserve the size of the data. Okay, so it's a basically a non-linear technique. So autoencoders is basically used in machine. I can say autoencoders is basically used in under neural networks. Autoencoders comes under the I can say deep learning technique. But not autoencoder, as I already told you, PCA is used for linear, and autoencoders are used for non-linear. There is no difference between PCA and autoencoders. Only difference is linear to non-linear. The functionality remains exactly same. What happens in PCA and autoencoders? Okay. So next is the uniform manifold. Sorry. Uniform manifold approximation and projection. This is UMAP. This is also a non-linear method. And this is, some of the, I can say this is one of the new methods which is actually coming or which came into the picture very recently. This is actually, it's a very important method, used for a, um, I can say, which is used to replace the, TSNE technique. When we talk about this, PCA and autoencoders also, when we see the data kind of right now, more the data is about, you know, more data which is coming in right now is more of non-linear. That is in where, the autoencoders use has become more in the market, in the industry, compared to that of the PCA. Okay, so because we are not getting the linear data much. Okay, so if the data is linear, you should consider yourself very lucky, because the methods also will be a straightforward methods. If you have to apply, if you have to apply, for dimensionality reduction. But that is not the case with autoencoders. Autoencoders, since it only applies on nonlinear. So, and the data kind of right now, which is in the industry as well, it's more of nonlinear. So definitely we need autoencoders, and we use this uniform manifold approximation and projection techniques, because this is, this method actually works faster on the data. So, there are some of the applications in dimensionality reduction. So they are basically help to reduce the noise in the data, and to preserve the important features, right? Reducing the size is one thing, and also the very important thing is to preserve the very important information which has to be used in building a model. So challenges is, losing the information is a very big challenge. So to retrieve, that is why I already told you that we try to retrieve at least 95%, which is the benchmark which follows the normal distribution. So 95% of the data should be retained after you reduce the size of the features, or to reduce the, you remove some of the features. So that is very important. That is where the risk, if you're able to, address that challenge, the loss of information is completely ruled out if you're able to do that. So interpretability is reduced. We have to make sure also that the reduced variables are not is not having any meaning, which will not impact, because you are removing that variables. So that, you have to make sure as a human being, you can't rely 100% on a machine for that. So you have to think out of the box, and you have to have, that mindset. So next is over reduction. So eliminating too many also is very dangerous. As I told you, 35 features, if I reduce to 20, I may, skip some two, three, which are very important. What if, they are playing a very important role, but, when I apply the mathematical or statistical methods, it is telling that, I can reduce that feature. This should not happen. So this should not happen. This over reduction is also very dangerous. So applications, data visualizations and all this, we have already discussed. So this is where, we apply in different fields, right? So particularly in data visualizations, noise reduction, signal processing is one area where we are using this machine learning, particularly dimensionality reduction. So in particularly, removing that minor variations in the sensors. Okay, so the reducing that noise is what, for example, if you use mics in mobile phones, cameras and all, reducing that particular noise is where the noise reduction technique is being applied. So compression is where to reduce the size of the data to retain that particular things. So this one, these are some of the applications we can, go through later. So sorry, challenges I've already spoken about. So challenges of dimensionality. So already I think compression, yeah. Recommendation system is one area where, most of the, I can say, whether it might be e-commerce, whether it might be, uh, maybe OTT platforms, right? Online shopping, everywhere you can see these recommendation systems, where the dimensional reduction plays a very important role. And then the informatics and all, gene variations and all, we are using the PCA. So text mining and NLP, and concepts on text mining and NLP, we will anyway discuss using a project and all, how we can apply the sentiment analysis and all those things. And anomaly detection, finance, to understand the stock prices, market trends. right? So for all these areas, we are actually covering the wherever uh, there is no as I already discussed on this. There is no field where machine learning is not useful. So everywhere we are using machine learning ML to understand things. So obviously the dimensionality reduction also plays a very important role in every field. So challenges we have spoken about loss of information and interpretability issues and all. So over reduction and non-linearity in the data. So non-linearity in the real world data is a very important thing which you need to understand, because as I already told you, the the reality is most of the data coming in right now is all non-linear. So curse of dimensionality, we call it as curse because sometimes reducing the size goes hayward, doesn't go as per planned, and still that particular problem is still persisting, dealing with higher dimensionality data. So relying on completely statistical methods to reduce the dimensions, statistical and mathematical methods is kind of a little risk. That is in where our expertise and our understanding of the data is extremely important. So sensitive to noise is very important particular thing. So noise is nothing but the unnecessary things inside the data. Okay. So these are how to overcome the challenges. Okay. So I can just go through later. Right. So I wanted to cover even this regression part and classification and how this regression works and what is regression and all those aspects. So regression and classification are very important, things. So let me just check up for any questions. So from tomorrow, we'll take up a project and we'll start with the. I just wanted to have an introductory session to make sure that what is this machine learning, and why we are using this machine learning. What does this machine learning actually do, and how it plays a very important role. What I just want to make sure that what exists in machine learning first of all, and how we can take up from there. So if this will be a session where you can just make sure that you understand what is machine learning and all those things. From tomorrow we'll go with the algorithms and implementation on the real-time data sets. So we'll make it more practical. As I just wanted to mention as well, you can log in through your laptops as well, so you can use this Anaconda Navigator to use the Python, uh, the code what I'm trying to do. So that should be better. So definitely because it's not just me explaining the project and you just listen. It's very difficult for you to understand what I'm speaking as well. So maybe you can in because we'll take a little slow to understand how the projects and how the algorithms are implemented. Then we'll go little fast to make sure we cover multiple projects on different algorithms and all. But initially we'll go a little slow. So maybe you can log in with your laptop and you can practice along with me to understand certain things. So I take it very slow since it's a little theoretical, just basics to understand what is machine learning and all. I maybe I've done a little fast, but I'll take it very slow. I'll take it very slow for the practical part, because that is in where the understanding and implementing the theoretical concept is very important. So I'll take it very slow there. Okay. So maybe you can do along with me. So I don't think any questions. Okay, fine. So I'll continue we'll continue for another 5 minutes. Okay, fine. So let us understand. Let us understand that what is this classification and regression part is more about. So there are two primary types in supervised learning, which is the classification and regression. So both are based upon training on the labeled data. So regression is more focused on predicting the numerical value or the continuous output. And what are the examples is where we can see that we are trying to estimate the target variable, which is a numerical value that we already have understood. So these are some of the examples where predicting the house prices, locations, amenities, stock prices, right? All forecasting, right? Temperatures, predicting the temperatures, all come under regression. So now let us understand the types of regressions as well. So types of regressions, there are multiple types of regressions where we have the linear regression, polynomial regression, logistic regression, ridge, lasso, elastic net, and you know, um, and then we have the support vector regression. So these are some of the methods which are available for regression. So these are some of the metrics which I was speaking about. We have something called as a mean square error. Then we have root mean square error, and then we have mean absolute error and R squared error. So basically, in this, the primary important thing is the mean square error and the root mean square error. And now, mean absolute error is not used much, to be fair. Okay, because absolute difference doesn't give you much of the analysis. It is existing, but we don't use it much, to be fair. Okay. And R square is very important because R square basically explains the variance in the data. So how much of proportion of variance is explained by the model, that R square will tell you. So that I will explain, when we do the modeling and all. Okay. So classification is where the prediction of the categorical variables. So whether it is something which can be categorized. So the target variable is a categorical variable. So something like predicting the emails. Then we have the prediction of the diagnostic in the medical data. Then image recognition and sentiment analysis and so on. So these are some of the classifications which you know a classifier does. Okay, so if you're having only two outcomes, it comes under a two classification, which is it's called as a two classes or a binary classification. So more than two, we are calling it as a multi-class classification. Okay, then we have the multi-label classification where we have multiple labels at each instance. Then there are some of the popular algorithms like the logistic regression, which is used for binary classification. We can use for multinomial also. For decision trees and then random forest, support vector, k nearest neighbor, neural networks. So all these things are used for classifications. Then we have metrics for classifications. So we have seen the metrics like R square, root mean square error, mean absolute error, right? Mean square error. All these metrics are for regression problems. For classification, it's a different story. So for classification, we use the metrics like accuracy, precision, recall, F1 score, AUC and ROC curve. These are used for evaluating the metrics, right? And when to use this regression versus classification. So I think by already now you would have understood when to use regression algorithms and when to use the classification algorithms. Okay. So, introduction to what is linear regression and, why, what we do in linear regression. We can, see it in the tomorrow's session, right? So maybe I can stop it here so that we can, so you can take over.
Yeah, yes, sir.
Hi, yes, yes. Thank you.
Yeah, so students, I hope you all enjoyed the first day of the session. So as Shashank sir has explained you very well, so you have to like practice. As you all know, the recordings will be visible. The same recordings will be visible on your LMS dashboard also. So if you have any doubt, you can just repeatedly watch this video. If you have any doubt or concern, you can just ask us back by tomorrow in the same session. Okay. I hope you all marked your attendance. I have shared the attendance link on the chat. So today is the day one. So the attendance is very important to be marked. So kindly mark your attendance. I'm sharing once again on the chat. Sir, is there any questions to be addressed from your side?
No, ma'am. I'm just checking the chat.
Okay.
Not much.
Okay, we'll wait for 2 more minutes. If students has any
Sure, sure.
questions, so we can reply for that. Students, kindly text on the chat if any questions we can like you wanted to know, we will answer for that.
I can see one question where which algorithms are important. That is, to answer that question, there is no such algorithm like this is not important. Okay, so every algorithm has its own way of being implemented in the reality where for the data we are going to implement. So it's very important to focus on each and every algorithm, right from, if I say right from, it may be linear regression, it may be logistic, it might be, decision trees, that's why, the best algorithms, which are actually used in the industry and, which algorithms are very important for us and which actually helps us, right? So those algorithms we are covering in this part of this 30-hour journey as well. So, maybe, in the coming sessions, this doubt maybe, I can, clarify rather than just telling you that all the algorithms are useful, because I know, because I've done some multiple projects. So, I can say every algorithm is important. Okay. You cannot rule out any algorithm. Like, you cannot say this algorithm, is not important, or this is very important and all. So you cannot say that. That is one thing you should never tell. So you should never tell when it comes to machine learning. So practice session will start from tomorrow. We'll start implementing. We'll just see what is linear and logistic, and then we'll go with the practical sessions. You know, we'll try to implement, start, with decision trees, random forest, and all, because they are very big algorithms which are very important in our context of journey of machine learning. So maybe you can, be ready with the tomorrow session with your laptop with Anaconda Navigator installed. So Jupyter Notebook working. So that should be, um, you know, that will help you to understand what I'm going to explain and how, things work in the real-time projects. So if you have any other questions, I can answer. Install tomorrow session for practice sessions. You can install Anaconda Navigator. Okay, so you can install Anaconda Navigator and you can just give me a minute. Just give me a minute. I'll post the link. Yes, Python frameworks play a very important role. Even the deployment part, we will see. Okay, so how to, test the project and how to deploy it in the real scenarios. that also we'll see in the coming sessions. So any other questions?
Yes, sir, I think there is no questions to be addressed. We all clear. So yeah, we'll wind up for the day. We'll meet again by tomorrow. So students, as sir told, whatever the necessary application, kindly install it and be prepared for tomorrow's session. As you all know, tomorrow will be the same session will be at 7 p.m. Okay. We'll meet again on tomorrow at 7 p.m. Thank you all for joining this wonderful class. Thank you all. Good night. Good night, sir. Thank you so much.
Yes.